Fabulous. Okay. All right. So, thanks for coming. So a little bit about me, in case you don't know. My name's Eric Niebler. I started at Microsoft in '96, a long time ago, in the Windows 2000 group. I've worked at Microsoft for about 7 years. I quit, and I've been freelancing since 2003. I've been a member of the C++ Standardization Committee since about 2004. I participate in the development of Boost, and I'm on the steering committee, and I'm a release manager also. So I get my hands in a bunch of different pies in the C++ community, and that's how I like it. I'm mostly a library guy. I don't really mess around with the language so much. I'm not a compiler dev or anything like that. But I really like designing interfaces and making C++ code that is a joy to use and reuse. And that's kind of what this talk is going to be about. This talk is going to be about ranges, and what are ranges? If you call a C++ standard algorithm, you have to call begin and end to get iterators to pass to an algorithm. And wouldn't it be great if you didn't have to do that, if you could just pass a vector to std sort? So that's the basic idea behind ranges, but of course if that's all there was to ranges, this would be a pretty short talk. As it turns out, the rabbit hole goes pretty deep. Once you open the door, there's a lot of fun things that are possible. So this talk is going to be about the fun things that are possible with ranges from the perspective of users writing code. Not going to get into the nuts and bolts of how ranges work under the covers. This is mostly going to be a talk about how ranges change how you can approach coding problems. Who, by the way, is in the D community and uses the D standard library and its range-based interface? Well, okay, some of you people. The cluster of D community over there. Yeah, censored, yeah. Andrei Alexandrescu, who is a, you all probably know as a C++ programmer, he moved over to the D community and he re-implemented their standard library to be range-based instead of iterator-based. He gave a talk called Iterators Must Go, about all the problems with iterators and how great ranges are and how fabulous range-based interfaces are, and how don't you all just want to quit C++ and move to D. No, actually. I don't want to quit C++, and I don't want to drop iterators. I don't think they have to go. I think iterators are a really powerful foundation, and we can build range-based interfaces on top of them. So that's what this talk is going to be about. And in fact, I stole the idea from this talk directly from the D Wiki. There's this great article on the D Wiki called Component Programming with Ranges. And it talks about this really cool programming example and how to solve it using ranges in a very beautiful way. And it's all in D, and I thought, God, we could do so much better in C++. So that's what this is going to be about. So we're going to talk a little bit about, we're going to learn, as we work through this one example, what parts make up the whole, all the different pieces to the range puzzle and how they fit together, why you should care, and we're going to talk a little bit at the end about standardization, because I think it's really important that everybody have all of this stuff out of the box. Okay. Here's the example. There's a command line application called calendar. You type a calendar year, and it formats that year's calendar to the standard output. Okay. It's kind of a messy problem, right? Dates and times, these are really messy human systems. We've got some months like February, they've only got 4 lines taking up the formatted calendar, and here's May. It's got 6. Sometimes the first day of the month doesn't start on a Sunday, right? So we got to figure out the white space. We got to figure out all of this other spacing business. And the real problem, why this is a challenge and why this is an interesting problem, is because the console is not a random access thing. You have to stuff things to the console serially, one at a time. And we're going to be generating data, like the dates, in chronological order, as you might imagine, but that's not the order, if you look at at which they need to be written to the console. So there's some like impedance mismatch with like the order that the data is generated and the order in which we need to write it out to the console to get things to look pretty. Okay. So all kinds of interesting messiness here. You might expect the solution to be equally messy, but in fact, it's really mathematical and really beautiful. And pretty short. In fact, twice as short as the one on the DWiki, but never mind. And here it is. This is the solution. Well, let's dive in a little bit deeper. So step 1 is very simple. It's going to be to create a range of dates. Has anybody used the Boost date time library? I think it's really, really handy. Yeah, of course. Because I don't want to have to write a date time library, and I'm really glad that somebody else did it for me because it's a messy problem. So here's how you work it. You include the Gregorian date calendar. Here we create some aliases. By the way, this is all in C++ 14. So there might be some parts of this talk where you look at syntax and it seems strange to you. And if you're not familiar with C++ 14, you see something that you don't understand, please interrupt me, raise your hand, and I'll be happy to explain. Okay. So we create a date, November 5th, 1955. Does anybody know the significance of that date, by the way? What's that? No, my birthday? No. The flux capacitor was invented, yes. So this program prints out the date as you would expect, November 5th, 1955. All right. And now, there's a range library that I wrote. You can find it on GitHub. And we can use it to create ranges of things. In this case, let's create a range of integers using view iota. And the integers go from 1 inclusive to 11 not inclusive. This is a half closed range. And print it out. And this is what we get. So I'm kind of like, I haven't really said yet what ranges are. This function call is going to return an object, a temporary object. That object has a begin member function and an end member function, just like a container does. It's not actually a container. It doesn't contain, it doesn't return a vector of integers. It returns something that generates the integers on demand as you iterate through this sequence. Okay. So you can kind of think of this as a generator. And what it generates is the integers 1 through 10. All right, any questions about that one? Yeah?
Where do the brackets come in?
Okay. So where do the brackets come in? You notice I'm just writing this object out to see out. There is a single range-based inserter, O-stream inserter, that can take anything that looks like a range, that is anything that has a begin and end member function, and it will write it out to the O-stream using square brackets and comma separators. That's just the hard-coded default range output that you get when you use my library. It's really handy for debugging, just to have a way to just like send a range to the output and have it formatted.
So just to clarify, this O-stream inserter is part of your library?
Yes, yeah, the O-stream inserter is part of my library. Yeah, yeah, you don't need to write that. This code compiles and runs, and this is what you get. Okay. So like I said, you get begin-end members that return iterator sentinel pairs. I'm going to kind of gloss over the fact that end can actually return a sentinel instead of another iterator. It's not really important for the purposes of this talk. So it's a lazy sequence algorithm. I said it's kind of like a container that generates its elements on demand. Another way you can think of it is as an algorithm that's turned inside out. It's an algorithm that, if you're familiar with like a coroutine from a language like C# where you have these yield statements, where you loop and then you generate data and then you yield data and then you can use a range-based for loop to iterate over that stuff. That's kind of what it is. It's like an algorithm that's turned inside out. These are lightweight and non-owning things. That is, like I said, they're not containers. They're not these heavyweight objects that copy all their elements around every time you copy them. They're really small, they're really lightweight. They're composable. I'll show you what I mean by that. We're going to see lots of examples of composing ranges. And they're non-mutating. So you can iterate over them, and they don't change state in your program. They don't write through to any underlying data store. And this is really nice because it means that you can program with them in a pure functional style with no side effects. Okay, so we should be able to create a range of dates. We saw that view iota counted from integers. It would be nice if it could also create ranges of dates. But as it turns out, dates are not incrementable from the boost datetime library. And this is the error that we get. We get a static assertion failure. The object passed to view iota must model the weakly incrementable concept. That is, it must have pre and post increment operators, and it must have a difference type. Well, it's a bummer that it doesn't work, but at least we get a decent error message and we know exactly what the problem is. The range library is defined in terms of concepts. Concepts are a language feature that, well, they went in to the C++ OX language, then they got ripped out, and then, no, they're trying to be added back in. So there's a lot of back and forth about this language feature called concepts. What concepts are is like clusters of requirements that you place on types. An iterator is a concept, for instance, right? The algorithms work on iterators, but there is no one single type iterator that you all need to inherit from in order to get iteratorness, right? It's just a concept. It's the sort of thing like a cluster of requirements. So here, what I'm saying is, iota is implemented in terms of this concept called weakly incrementable. And here are the requirements on the type. Pre and post increment operators and a difference type. That's all. So we can kind of force the issue here by defining those operators ourselves in the boost namespace. And when you do that, you can actually iterate over dates. And that works. In general, don't do stuff like this. That is like opening up somebody else's namespace and stuffing in your own overloads in there. It's fun and it can be really convenient. And okay, I'm up here telling you, this is how I did it. But don't do it in general. Okay. So we've just created a range of dates. And that's a good starting point. But we're not there, not by a long shot. The first thing we want to do is group the range of dates into months. Now, what do I mean when I say group? Well, we've got a range of dates. If we group a range of dates into months, then what we end up with is a range of ranges of dates, where all the ranges inside, they are all the dates within them all have the same month. Okay. And here's how we do it. We have a function called dates in year that takes a year and returns all of the dates in that year. And here, we take that range of dates and we pipe it, I'll explain that in a second, to this adapter called view group by. And this is a lambda function. So group by takes a function that takes two arguments, two dates, and returns true or false, whether they should be grouped together or not. So this pipe operator is how we compose operations on ranges. I can take a range and I could pipe it to an adapter. So that adapter takes in that range and spits out another range that has different behavior. In this case, the different behavior is that the dates that belong together are grouped together. So what we end up with, months, which I create here, I can iterate over it, and what I get at each iteration is a month. And the month is going to be a range of dates. I can grab the first one and print it out. Yeah, question?
Are you generating an n-squared problem when you do the group by?
So am I generating an n-squared problem when I do the group by? The answer is no, because group by is actually pretty stupid. It only groups elements that are next to each other. Right. So only dates that are next to each other can be in the same group. It doesn't find all of them, just consecutive ones. Which works out well in our case because that's all we care about. Dates that are in the same month are necessarily all consecutive. Yeah. Yeah.
Is group by lazy or eager?
Is group by lazy or eager? It is lazy. Everything is lazy. Yeah. So we don't actually carve up the dates until you actually iterate over it, which is really important because this could be an infinite sequence of dates. And this still works. Yeah, question?
So the pipe operation is able to provide access from the range before it to the range or the tool after it, multiple items at a time? Which would have to be the case here, or is group by, how is group by able to access 2 dates?
So how is group by able to access 2 dates? So group by is an object that is going to wrap this one. It's going to copy it and store it in a local variable, or yeah, in a member variable. Okay, which means that it can ask for its begin and end iterators, and it can walk from the beginning to the end, right? And it can save an iterator here, and it can increment and get access to the next element, and then it can ask at those 2 positions, should these 2 elements be grouped together or not? Yeah. Okay? Yeah, question?
Does it copy the iterator or does it copy the value that the iterator actually points to?
Does it copy the iterator or the value? It copies the iterator. It doesn't copy the value. Yeah. It only needs to remember positions. All right. So when we do this, since we're printing out the first day of each month, we get the first day of each month, January, February, March 1st, etc. Okay. Let's clean this up a little bit. Here's the group by expression from the previous slide. It's the same thing, nothing changed. I just put it in its own function, called it by month, and here I just use it year by month. We're going to use this trick a lot. It makes things pithy and kind of easy to talk about. Easy to write, easy to read. Otherwise, it's the same code. Have you guys noticed yet, are you familiar with C++ 14's automatic return type deduction? I don't have to say what type this function returns. It's deduced from the return statement. It's really nice. Yeah, question? Is group by a function or a constructor? It's a function. It returns an object. You don't actually know, and you don't particularly care what the return type of group by is. I mean, there is actually an object called group by view, and that's the actual type that it returns. But you really never ever need to say group by view in your code. You don't care what the type returned by group by is. It's just a thingy that behaves like a range. It's got a begin and end member function. It's got the behaviors that you want. Okay. So the range library comes with a whole slew of interesting and useful range adapters. We're not going to use all of these, thank God, but this is some of them ones that you can play with. There's zip, there's replace, here's group by. I can generate stuff on the fly from a function, concatenate two ranges. We're going to see an example of that. Lots of useful, interesting stuff. All right, we've grouped the year into months. Now we can group the months into weeks. By week, we use group by again. Simple enough. The only snag here is we have to actually increment the two dates when we're grouping by weeks, because the Boost Datetime library wants all of your weeks to start with Monday and end with Sunday, and I don't like that. I like weeks to start with Sunday because I'm an American. Month by week. So here, remember that when we take all the days in a year and we carve it up by month, what we end up with is a range of dates. If we want to carve months up into weeks, we have to reach into each one of those months and apply the transformation inside there. So we use view transform to do that. Just like stood transform, which applies a function to elements in a range, view transform is going to take in a range and apply a transformation function to each element in that range. So I'm going to be reading in months, and I'm going to carve them up into weeks. So this ungodly thing takes a range of dates and produces a range of ranges of dates. Year grouped into months, grouped into weeks. Yeah, question?
What confuses me here is the overloading of the bitwise OR operator into something vastly different.
So yes, we're overloading the bitwise OR operation, and this is something vastly different. We are definitely not doing bitwise OR. But if you've used the Unix command line, this should be somewhat familiar to you. Right? You can execute a command on the command line and pipe its output to another function that munges that, and you can pipe that output to another function, right? That's the exact same programming model.
So it's a pipe operation?
It's a pipe operation. Yeah.
So you also have less than, greater than, and double greater than, and all that stuff.
Do I also have less than, greater than? No, I don't. Just the pipe operator. Yeah. What would that be useful for? Well, that's an interesting question. Maybe sources and sinks. I'm not sure. Yeah. Okay. Yeah. Oh, right. Range is 4. So I had glossed over the fact that the type of the begin and the end in my range library can actually differ. Rather than begin and end returning two iterators of the same type, I can have begin and end actually returning objects of different types, as long as I can compare them for equality. And that actually makes the built-in range for loop have fits. It doesn't like that. So this is just a hack, a temporary hack, until I get the necessary language change to make that work. Yeah. Thanks. Yeah, question?
What does actually do? Because you are comparing the values. If 0 is equal to 0, then 7 will be equal to 7. So it looks like it won't change the Boolean statement.
Right. Okay, so the question is like, this doesn't look like it should have any effect at all if I'm incrementing both sides before doing the comparison. But think about, okay, if, so remember that week number is only going to return, a true, no, it's not going to return a true, it's going to return an integer saying what week in the year you are, right? And so if you're currently on the borderline, like if it's a Sunday, right, then week number, because it reports dates Monday through Sunday, it's going to think you're in the last week, right?
Oh, the week number is not from 0 to 6, essentially.
Right. So week number is going to be like 0 through 52 or something like that.
Okay.
Yeah, like which week in the year are you in? Yeah.
Did you consider any other operators besides the pipe?
Did I consider anything besides pipe? So comma would be really problematic because of its extremely low precedence. Things would just group weirdly. Bitwise OR is pretty low, but not as low as comma. Yeah. So no, I didn't consider any others because this is kind of the way I think about the problem. And this is actually taken from the Boost Range library, which has used this syntax for quite a while. Yeah? Is this stuff done by reference or by value? Yes. These adapters, I mean, notice that there is no data to reference. When I'm doing this, everything is being generated on the fly, right? So you could say this is all being done by value. Okay, but imagine instead of like a range that gets generated on the fly, imagine I have a vector of dates, right? I should still be able to create a view of that data that is by month and carve that view up by weeks. And in that case, I'm actually going to be referencing the dates. I'm not going to be copying them by value. Because you shouldn't have to copy that much data in order to just create an interesting view on that data. Yeah?
Do you have a way to have a pipeline like this take in through some adapter or something, an actual container of objects?
So could I take in an actual container of objects? So like I just said, if this is actually a vector of dates, that works.
Okay.
Yeah. But it doesn't copy the vector into the view, right? If I say vector pipe by month, right, this is a view of data that lives elsewhere. And in fact, if this were to return a temporary vector, this line wouldn't compile at all. You're not allowed to create a view of temporary data. Really, I mean, if you think about it, that doesn't make sense. Because the data is going to be going away, and you're going to be left with a view to data that doesn't exist anymore. Okay? So if I have like a local variable that is a vector of dates, then I could use that local variable in this, and I will be creating a view of data that lives in the local vector. Yeah. Good questions. Okay. All right. And when I print all of this stuff out, notice I just, I transformed each week by only pulling out the day because I don't care about the year and the month. So this is what it looks like. And it's already starting to look a bit like a calendar, and I think that's pretty great. We've really done very little work so far. Cool. All right. Clearly we need some formatting here, and I hate formatting. A bunch of fiddly string manipulation. But there's a library in Boost called the Boost Format Library, which makes it very painless. The problem with it is, just like with std_printf, you got to memorize these cryptic escape sequences, and it kind of looks like line noise. So I apologize in advance. I'm going to show you line noise and wave my hands and say it does the formatting. Okay. First function is called format day. It takes a date and prints the day, rips out the day part of that date, prints it in a field that's 3 characters wide. That's all. And now I have a function called format weeks. It's going to take in a month grouped by weeks, and it's going to write out month with formatted weeks. Okay, just a range of strings. So I'm going to transform each week by doing this magic line noise cryptic thing, okay? And what it means is I'm going to print out like 1 field and 2 fields, and then I'm going to print out that whole thing in a field that's 22 characters wide. Okay. This is just white space. That is like, where does this week start? If the first of the month is a Wednesday, I need to print some white space. So this is the white space, the day of week times 3. And then the rest of this the week transformed by format day is going to return a bunch of strings, and then I join those strings together. So I take all the formatted days, which are a bunch of strings, glue them all together, and that's what this does. I'm going to come back to this because it's interesting. And laying out the months is I just apply this transformation to all of the months. I carve the month up by week, and I format the weeks. Okay. Now, this action join is pretty interesting. What Boost format wants is strings. Right? What I've been doing is transforming ranges lazily. Right? If I were to transform this lazily, right, I'd end up with a range of characters. And Boost format doesn't know what to do with a range of characters. It wants a string. So I actually have to take strings and I have to glue them together, and this is an eager operation. Eager operations are very different than lazy ones. So they get different treatment. Views are lazy. Actions are eager. They do the work immediately. So that's what's going on here. Range actions are eager sequence algorithms. They can operate on and return containers. Yeah, Walter.
So action join allocates memory?
It allocates memory.
Who creates the memory? How's that handled?
So it allocates memory for a new string, fills that string in, and returns it. And it's a temporary object. That object, it's got a destructor.
Okay.
That destructor frees the memory. It's just a stood string.
All right.
Yeah. Just like the views, range actions are composable, but these can actually mutate. So I can write an action that actually inserts things into containers, like does stuff to a container, right? Builds new ones, mutates existing ones, etc. And here's how they stack up, the views and the actions. Views are lazy, ranges are eager, etc., etc. Views, totally non-mutating. These things can actually write stuff. All right.
Question.
Yeah.
What do you mean by composable on the actions column? Like, can multiple actions be types?
Yeah. So the actions are themselves composable. For instance, you can read a bunch of data into a vector. You can pipe it to a sort action, which sorts the vector, and you could pipe that, the result of that, to a unique action. So you can take a vector, sort it, and unique it, so you end up with a bunch of unique elements. Just like you would do on the Unix command line. I can pipe stuff and unique it on the Unix command line. That's just like this. Yeah. Okay. Here are the built-in range actions. There aren't quite as many as the views, because this is kind of a newer part of the library. I just haven't filled this part in yet.
Sorry, one
Yeah.
question. So are they then not objects?
The views the actions?
The actions don't return objects.
The actions absolutely do return objects. Yeah. So
If I pipe a series of actions and views with action in the middle and views on both sides.
right. So this is an interesting thing. So if that action, like action join, is returning a temporary string, remember how we said we can't take a view of a temporary container. So actions can be at the end, but you can't then pipe it on to create a view. You have to actually assign the result of that action to a local variable and give it a name and a lifetime so that you could then manipulate it via views. Yeah.
So also, are you saying that, to use your sort and unique example, because they're actions, if I had 10,000 of the same value, I would still have to create my sorted array of 10,000 elements before I uniqued it, removed it, and have another temporary say.
Yeah. Yeah, exactly. So that's a good point. There's another important difference between views and actions. When I create a pipeline of a bunch of different views and then iterate it, I am traversing that sequence exactly one time. right? But if I create a pipeline of a bunch of actions, and each action has to operate eagerly, I am traversing that sequence over and over and over again. So there's, yeah, each action. So there's a difference in algorithmic complexity when you deal with actions and views. Views are actually, it's a really nice property that when you create a view and you traverse it, you're visiting each element exactly one time. That's really nice. Yeah. Okay. So this is where we are so far. We can take a year, carve it up by months. I could lay out the months. I can iterate over the months and then iterate over the weeks and print them out. And this is what I get. That looks a lot like a calendar now. Yeah. Missing the month title. And also notice, okay, here's February, it's 4. And here's March, it's 5. If we're going to be laying these things out side to side, we got to make sure that they take up the same amount of vertical space. So we're going to have to worry about padding. So we need month title and padded weeks. Month title is really simple. The Boost datetime library solves that problem for us. As long string, month.asLongString, that'll give me January, February, March, April, May. Format it in a buffer 22 characters wide, centered. That's that cryptic equals 22. And here's the layout months function from the previous slide. We've changed it a little bit. Instead of just returning the formatted weeks, we're going to concatenate a range to the front. And that range is going to be the month title. So I take the first day of the month, I pass it to month title, I get either January, February, March, April, May. I turn it into a single element range. There's a range with one element, that's going to be the month title. And I concatenate that range with this range. Again, this is all being done lazily. Create some fancy iterator that knows how to do all of this stuff. All right. And now we get month titles. That's pretty simple. Any questions about that? Yeah?
So does this work because the date, or the day number is actually a string like the month name?
Does this work because the days are strings? Actually, the entire weeks are strings. If we go back and look at format weeks, format weeks, what we're going to be doing is we return a string, right? So the string is going to be the result of this action and this white space formatted into 1 week, which is like a line, right? A line of just 1 week. That's going to be a string. And so what we end up with here is a range of strings. And this is going to be another range of strings, got exactly one string in it, so I can concatenate those two. Yeah.
Mark, is anything padded out here on the month's names padded on the right, or is that the other?
Yeah. So this is doing the padding here. That crazy syntax means, you know, it's centers and pads. Yeah. It's pretty nice. I'm glad that I don't have to write that. What's that? Where are the new lines coming from? Yeah. I'm just writing it out here. That's the new line. And I'm getting, you know, these dots over there. All right. All right. Okay. So here, formatted month is as many as 4 and as many as 6 lines. For side by side, they must occupy the same vertical space. So we're going to have to insert, you know, some variable number, either 0, 1, or 2, blank lines. Pad the months out to the same length. Okay. So we count the weeks by passing the month. I carve it up into weeks, and then take its distance. That's going to be 4, 5, or 6. All right? And here's our concatenate. That was the same as what it was last time. And here, I create another view, which is just some padding strings. 6 minus the week count. That's going to be 0, 1, or 2 lines of padding. Concatenate with the other strings that we've generated already. And now we get padding. Great.
So that distance looks like it's the first time you double the amount of running your ranges. Up until that point,
Yes.
everything has been hit only once.
Right, right. So, yeah, good point. This is causing a doubling. We traverse twice. We have to traverse once to count the thing, and another time to actually generate the thing. We could code it differently and be smarter about that, but this is short and sweet. Yeah. All right. So here's where we are so far. Year is a range of months. Month is a range of strings. Each month has exactly 7 lines in it, 7 strings. By month and layout months, reusable. Work even if the input range is infinite. So we can create an infinite range of dates, and we could just keep spewing out formatted months forever. Until the datetime library gives up, that is. Which is around the year 10,000. Cool. So, all right. Whew. Yeah. Kind of feels like we're almost there, but as it turns out, we've got a ways to go. So, somehow we need to format these months side by side. Not exactly sure how. And this looks kind of complicated, but it's actually a little bit simpler than that. Yeah. So what we need to do is we've got a range of strings, a range of ranges of strings, right? And we need to get it from this format to that format. Now, you can kind of think of a range of ranges as a matrix, you know, with rows and columns. And so if we visualize it as a matrix, January, February, March, April, etc., we have to transform this into this somehow. Who thinks that they can describe in words the transformation that gets from the left to the right? Anybody?
Taking like every 7th or 8th or whatever, and then you're stopping at some point.
Who said transpose? Yeah, it's a transpose, but what do you have to do first? Yeah, yeah. You take 3 at a time, and you transpose rows and columns. Yeah. And then another 3, transpose. Another 3, transpose. Right? This is very precise and very mathematical. It's a very simple operation. At least in our heads, it's simple. Yeah. It actually gets a little interesting when you actually get down to implementing it. But that's kind of that's what we're going for. All right. So we chunk each month, chunk the months into groups of 3s. Then we're going to transpose the rows and columns. Then we're going to join the chunks that we created in step 1. Just glue them together. And then the strings of the inner ranges, that is the 3 formatted weeks of the months that are side by side, we kind of glue all of those together into single lines. And then we print, and then we take the rest of the day off. And then we head for the bar. Okay, so far, we've just been reusing the bits and pieces that the library gives us, right? But now we've run out of tools in our toolbox. We have a problem. We don't have a range in the range library for chunking, or at least I didn't when I first started working on this problem. Now, one of the arguments that I've heard Andre give for D-ranges is that implementing D-ranges is just so trivial, and implementing iterators is just really hard. And I agree, implementing iterators is hard. But I think it's actually a library problem, and we don't need to throw the baby out with the bathwater. We don't have to get rid of iterators to make it simple to create ranges. So here, I'm going to show you how to create a range. I'm going to do it on one slide. First thing we do is we create a chunk view, and it's going to take a range of things, and it's going to produce a range of ranges of things, where each range is a certain number of elements long. Okay, this is some boilerplate. I inherit from a range adapter. It's going to be, it's going to have the same behavior as the range it adapts, but we're going to tweak some of the member functions a little bit. So that's what we do with range adapter. All right. And here is where we say how we're going to be changing the behavior of this thing. Okay. I've got this function called begin adapter, and it returns an adapter. Ignore this for now. This will make sense in a second. Okay. And then range adapter is going to call begin adapter. It's going to get this adapter thing, and it's going to know how to mutate the behavior of the underlying range. Okay. So let's put that over there. Here's the adapter, right? It's going to inherit a bunch of default behaviors, and we're going to override current and next, all right? This is how I change the behavior of the underlying range. When this range's iterator gets dereferenced, rather than returning an element, I'm going to return a range of 3 elements. Okay, so current, that's the function that gets called when its iterator gets dereferenced. When it is yielding up a value, it's going to yield 3 elements by calling view take. Take the elements starting at this position, the current position that's passed into current, up until the end, create a range out of that, and take the first. This is going to be 3. First 3 elements out of it. Okay. So that's how I change how the current member function works. It's how I customize how the dereference operator works. And here's how I change how the increment operator works. I want to skip over 3 elements. All right. So I've just created a chunk view. All right. The only thing that I have to do, yeah, question?
Yeah, you did something similar with days function of weeks.
Yeah.
Mm-hmm. Why didn't you group months by 3 months?
So the question is, why didn't I use group by for this? Group by takes a function that takes 2 values, right? So I'd be taking 2 strings and asking whether they belong in the same group, and I don't know. Right? It's not positional, right? So group by is not positional. You don't get access to the position. I can't say like, I want to group things that are only like 3 elements apart. I don't get that. It's not the interface that we get with group by. So that's why I had to create a new one. That's a good question though. Yeah, Dave?
Why do you keep the default constructor?
Why do I keep the default constructor? For the chunk view, you mean, right?
Or either.
Okay. So it's kind of a philosophical thing. Sometimes it can be really handy to just create an object that's empty and assign to it later. It's how I tend to design things. There's so for instance, there's a lot of things in the standard library that kind of assume that things are default constructible. You know, if I create a vector and I give it a size of 5, those things had better be default constructible or I can't create a vector of them. So
Default vector makes sense. What's a default chunk view after me?
I mean, it's a fair point. It doesn't make a lot of sense. For consistency, I always give things default constructor if I can.
But if someone tries to use it, they'll try and take 0. What will that do?
Well, if someone tries to use an empty chunk view, well, that doesn't make sense.
It'll just spin forever.
Yeah. So I can, if this is 0, then this whole thing doesn't really make a lot of sense. Yeah. You'll spin forever. It's true.
Is it incorrect, or does it just do nothing?
It's actually incorrect. It'll probably hang your program. I mean, I can add an assert. I can add an assert like here or here that n is actually greater than 0, and I think that would probably be a good addition. But it takes up an extra line on my slide. All right. So I can create a chunk view, but I want like a helper, like an adapter, something that I could put in the pipeline, right? That will create a chunk view for me. So I create a function. I call it chunk. It takes a size. I'm going to chunk 3 or whatever. And here's some magic that there's this make pipeable function that takes a unary function and turns it. It's just basically a rewrite. So a pipe b turns into b called with a. So here, this will make a little bit more sense when you see how it's used. Okay, I can say v pipe chunk of 3. Chunk of 3 is going to return a pipeable object that's returned by make pipeable. And when I pipe a v into the make pipeable object, this lambda that's passed to make pipeable gets called, creates a chunk view for me. I know that's a little confusing. I don't want to spend too much more time explaining it. If anyone has questions, I'm happy to answer. Otherwise, I'm going to move on. Okay. So, little bit of magic prints our chunked vector. We've got a vector 1 through 10, and so now I get chunks 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Notice how this last one doesn't have 3 elements in it because we ran out before we got to 3. So, in just one slide, we got like an entire range built from scratch. All right. Now, transposing a range of ranges, this one really made me feel kind of stupid for a while. I really didn't have any idea how to transpose a range of ranges. If these things were actually matrices, it would be really easy because I can mutate the elements, I can flip rows and columns really easily. But I don't get random access to a range of ranges. These are forward accessible things only, and I can't mutate things in place. Data is being generated on the fly, so there's nothing to mutate. So how do I transpose a range of ranges? Can anybody imagine any clever transformation? Yeah.
It's easy. Create another view.
Create another view. Yeah, but how does the view work, right? You actually have to implement the view. Yeah. Yeah.
If you turn it into a long serial array of items, then you could iterate through it in the skip elements.
Oh. This is a smart man. Like, it took me about a day, and I think you're really close. So here's how I did it, and it's a lot like that. So you do this sort of, you flatten it into a single thing, right? By doing this sort of interleave iteration, and you end up with a flat sequence like this, right? January, February, March, January week 1, February week 1, et cetera, et cetera, et cetera. And now you just chunk it using the chunk adapter that we just wrote. And when you do that, you've just transposed rows and columns. Yeah, question?
Was this before the outer range should be finite?
What was that?
At least one of the ranges, outer range should be finite.
One of the directions has to be finite, but only one, right? So if each of these ranges are infinite and go on like to the right as far as you care to go, this method of transposing a range of ranges still works. You just get ranges that are infinite in this direction. Yeah. It's pretty neat. All right. So here's the interleave view. We get a vector of ranges. And here, we're using range facade instead of range adapter. We're creating something from scratch rather than adapting something else. Okay? But just like range adapter, range facade is going to access some type within here, and that's going to define how we build our traversal. Okay. Yeah, question? All right. So just like in D, where you define a D range by saying, where there's current, next, done, that sort of thing, this is how you build ranges from scratch. When you're not adapting one and you have to build one from scratch, you create what I call a cursor, and you define current, next, and done, and maybe an equals if you want to be able to compare positions. And so if you look at current and if you look at next, you kind of get a sense of how the traversal is happening. You create a range, a vector of iterators, and you traverse across that vector of iterators. This is like you're visiting each range in round-robin fashion, and then when you've reached the end of that, you bump all the iterators forward one. So increment n, when you get to the end, bump all the iterators, and then keep going. So this is how you build an interleave view. And here's our interleave pipeable adapter thing. And now I can interleave a range of ranges. And this takes in a range of ranges and interleaves them by visiting the first element of each, and then the second element of each, and so on. So you just interleaved a range of ranges.
I think you want that built into your library.
This is a really useful one, and I want to build it into my library. I haven't yet. Yeah. Question?
I was just going to say, there's the zip operator.
There is a zip operator, and a zip operator is a similar operation. The difference is it takes a finite number of ranges. Say you zip 2 or 3 ranges together, and you'll get tuples of elements. And they can actually have different types. So I could zip together a range of integers and a range of strings, and I get back a single range, which is a pair of ints and strings. Right? Doesn't help us here to do the interleave, but it's close.
Well, you could use this if you had a lot of telemetry. You have a whole bunch of tables inside of some other table on a line.
Yep.
You have something at the front that says, oh, we got 17 is the length of each of the subtables. Okay, you got a table of integers, a table of integers, a table of floats, and a table of integers. And then you can zip them together so that you've got integer, float, integer.
Right.
And a whole bunch of those. And then they're more meaningful to look at. And that might be fine for telemetry, but if you're going to analyze it with the spreadsheet, you'll want to see the things
in table format. That's right. Yeah. So the point was it could be really useful for telemetry to have the zip view. Yeah. All right. So we've got chunk, we've got interleave, we've got all we need. Now we have transpose. Transpose, we take in a range, we pipe it to interleave, and we pipe it to chunk. Whew. So I can transpose a range of ranges, just like that. Okay. This is where we are in our list. We've grouped, we've transposed, and all the rest of this stuff, join, another join, print, we know how to do all of this stuff. This stuff is easy. Let's just skip to the end. Here's chunk. We lay out the months, we chunk the months, we transpose the months, we join all the chunks together, And then we reach into each month and we join all of the strings. We create a single range of strings and we write them to cout. Now, the only thing that's new here is transpose months and join months. These are really simple. To transform with a transpose and another transform with a join. This is joining strings now. Joining all of the 3 side-by-side weeks of each month into a single string so that I could write it out to the console. That's what you get.
That calendar is not the output of that program.
It's not.
Every month would have 6 lines.
Yeah. Let me see. What was that? So it's not because I'm not actually reading in the year from the command line. That's the only thing that's different.
No, the first one has an extra line, and then the rest are 6. Yeah.
No. These all have 7 lines. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2. They all have 7 lines. Because we added padding lines about halfway through the talk.
You don't need the first one.
Oh, this one.
There's one row.
This one, yeah, you don't actually need that one. I could glue it all together, but
Just look at, like, you know, you could figure out what the 3 months and what the maximum is with a little algorithm, and use that instead of the 6. But.
Sure. Yeah, I mean, I could be smarter and like avoid printing out a single like empty line when that's going to happen. But no. The last what? The last line is missing. Yeah. Yeah. And let's see if I can. All right. If I can show you guys. Here's the program. So I can format, say, 2014. And there it is. And you notice that I kind of read the number of months per line was only specified in exactly one place. You know, I could say per line 5. Now I get 5 on a line. And you know, say I want to format till I never want to end. And just keep spewing out formatted months forever. Right? I got all that for free, right? I didn't have to like specifically handle the case of 5 months side by side or an infinite range of dates. It all just works, and it falls out.
In Unix, when you type ls, you get a bunch of file names. With just plain ls, they're going to be kind of compacted, so they're going to be in columns. And the columns won't be the same width; they'll just be as long as they need to be.
Right. It seems kind of magical, right? It's got to figure out all of that stuff.
I like it or not.
Yeah, question.
So if you have infinite stream of input dates, can you do by 13?
Sure. I could group by 13 months if I wanted to. Yeah. Totally. You know, and if I wanted to carve things up by year so that I could say like actually what year I'm in, that might be a nice addition. But you know, I just kind of like, I got tired of doing it.
Switch it to Roman numerals. I think it's way back in the original formatting.
That would be a fun challenge. I don't know. Not sure whether ranges would be useful for that one. Yeah.
When you originally said you're going to do this with ranges, I thought what you'd do is build up a dynamic tuple, and I mean 3, that would be sitting there, each going down its own month.
Yeah.
Dynamically doing that month, formatting itself out automatically, so you wouldn't actually be storing and manipulating the strings of each one. You'd actually be printing out the dates as you went along. The trick would then have to be when you reached the end of the last day, you have to figure out a way so that it doesn't go on to the next month.
Right, right. I mean, it's actually really tricky to try to implement it that way. And you would have to have a vector of ranges and then march them all forward one at a time so you could like write stuff out to the console in the right order. I don't think you could do it without storing something in a vector if you do it that way. And then you have to worry about the boundary cases. It gets really tricky. Question?
So I have some performance questions, but I can wait until later if you have slides related to that more.
I'm not going to be talking about performance.
Okay, so then my two observations that I can see is, especially if you're using mostly views, you're kind of getting the advantage of thrashing your data cache a lot less because you're dealing with a lot less data.
Yeah.
Everything is almost code. But on the other hand, you are, because of the lazy evaluation of a long pipeline, let's say,
Mm-hmm.
you are probably more likely to be thrashing your iCache because you're for every operation, you're jumping from function to function to function to function that are possibly at very different places. So I was just wondering, like, maybe in this case it doesn't matter, like, with a small amount of data or a small chunk of code, but in a bigger scope, have you had experiences around how these things work when you start putting in actions, for instance? How do those trade-offs start impacting you? And I'm especially eager to kind of concentrate the case where if you were going completely data-oriented, where you treat the entire problem by like data transform, data transform, data transform, where it's very iCache and Vcache friendly. Compared to that, how does this set of idioms work?
So I actually think this is very friendly for both caches, even the instruction cache, because all of these function calls are inlineable. So the compiler can actually do a tremendous amount of optimization. I wrote a blog post about generating data on the fly using range comprehensions. And I used an example that Bartosz gave me, Bartosz Maluski, if you read his blog. He gave me this challenge. He wanted me to generate Pythagorean triples using ranges. And so I wrote a range that generated ranges, that is like, and then it concatenated a bunch of them together. And it was actually quite complicated code. Compiled with GCC at full optimizations, and it was 5% slower than like just nested for loops and gotos, which is amazing. Well, I compiled it with Clang, and it was 17 times slower. So I mean, there's, it depends on what compiler you're using. It's very sensitive to compiler optimizations.
I actually missed the inlineability here.
Yeah.
You're right. That makes a huge difference.
Yeah. All right. Oh, I lost my clicking ability here. Oh, that's why. Okay. Oh God, decal type of auto. Where did you see that? Oh, there. Yeah. Okay. Decal type auto. This is a C++ 14-ism. If I had just said auto here instead of decal type auto, and say this returns an integer reference. If I say auto, that's going to deduce the return type to be integer. Okay. If I say decal type auto, deduces the return type to int ref. So, as opposed to just having to say decal type and then repeat the expression in the decal type. Yeah. Okay. That's all. Okay. So the solution's composable, reusable, it works with infinite ranges. I can show as many months side by side as I want. I got that for free. Not a single loop in this entire program. Yeah. And there is exactly one if statement. And that's actually really huge, and I want to spend a little time talking about it because bugs come from state. When your programs have lots and lots of potential states that they can be in, that's where bugs happen. This program has virtually no state at all. No loops. Most things are purely functional. The only state we have are in member variables of those 2 views that we implemented from scratch. That's the only state in our program, very small, very isolated. We can manage that much complexity at a time. Right? Everything else composes together beautifully. It's correct by construction. That's the great thing about programming with ranges. So, like I said, this rabbit hole goes pretty deep. This is not just about passing vectors to std sort. Yeah.
Did you implement your views and actions in terms of your range adapters and facades?
Yes. Yeah, so the question was all of the views that are in the library, like the group by and et cetera, those are all implemented in terms of range facade and range adapter. Yeah. Yeah.
What exactly, I mean, you may have touched on this, what exactly is the relationship between all the stuff you've been presenting and any existing, future, proposed, dreamed of
ranges and standardization?
Plus XX.
Thank you very much. You kind of like, here's my very next slide. Okay. What's already been proposed? The range concepts that the library is built on have already been proposed. The range algorithms, that is like passing vector to std sort, that's been proposed. All this other stuff has not been proposed yet, but it's just for lack of time. I'm getting to it. The really good news is that when I gave a presentation to the C++ Standardization Committee in October last year, Herb Sutter pulled me aside and asked me, what will it take for you to be working on this full time? And I gave him a number and he said, you got it. And so I owe a huge debt of thanks to the C++ Standard Foundation, which in case you guys didn't know, runs the ISOCPP.org website. They are a nonprofit. They get funding from all sorts of different companies like Microsoft and IBM, et cetera, et cetera. And they have just started a grant proposal. So if you are writing standards documents and proposals, you can ask them for money. And they might give it to you. So I'm working on this stuff full time right now. This is my day job. And this is what I'm going to be doing for the next 6 months. This, and this. So here's how we are on the timeline. October, the initial proposal. 2 weeks ago, I presented a paper that had proposed wording for the concepts and the algorithms. And here's what's coming up. The next 6 months, we're going to be doing a detailed wording review. I'm going to be drafting some more proposals, hopefully the views. I need to talk a little bit about infinite ranges, because those are interesting and challenging from the perspective of the concepts. Range views and proxy iterators that generate data on the fly now become very interesting and kind of problematic. So I'm hoping that initial wording will be voted into a draft technical specification. It is kind of like a standard that gets shipped on the side. It doesn't become part of C++ officially yet. So hopefully we'll start working on this separate document, a separate standard. I can make even more range-related proposals next year, the actions, the facades, and adapters. Eventually a TS will be approved, fingers crossed, God willing. someday this becomes STL2. That's the hope and that's the plan. And by STL2, I mean this is going to be a second version of the standard library that will probably be in a different namespace.
Not STD.
Probably not STD. Although it might be STD and the other namespace is in STD::V1. It's probably going to be some opt-in mechanism. The problem is that adding concepts to the standard library is going to be very traumatic. And it's virtually impossible to add concepts without breaking at least some code, even if it's pathological code. And the committee doesn't like breaking code that works. So the committee really wants to clean up the standard library. They really want concepts, but they don't want to break code. So there's probably going to be a new standard library version that has concepts. That's what it's looking like right now, but it's all like up in the air. So, yeah, question.
Do you have any plans to provide any helpers or around integration of ranges and threading?
So ranges and concurrency is a very interesting issue. You'll notice that a lot of this stuff, pure functional, data generated on the fly, really great for concurrency and parallelization. There are other things, like a view of some region of memory. You might want to have parallel algorithms that know how to carve up this data and farm it out. You know, either do some sort of a fold, or spin up some processes, or you've got a thread worker pool. I mean, it's a bunch of different things. So the research is ripe. No one's actually sat down and done the work yet. But there are a bunch of people who are interested in this. You're not the only one. Yeah. All right. I think that's all I got. Here's some links. This is the paper that I presented October last year. This is the paper that I presented 2 weeks ago, so you could read all about it. This one actually gives you a little bit more of the philosophy and the design overview. And this is just actual detailed standardese wording. It's like reading a legal document. It's not terribly interesting.
We want to look for this on the web. We look for range. We look for Niebler.
Yeah, you look for Niebler. You look for range v3. This is the source code. Works on any conforming C++ 11 compiler. Emphasis on conforming. Sorry, Microsoft. Yeah, and you could use that today. All that code compiles today. Yeah. What happened to range v1 and v2? So it's a historical note. I started this library as just a slight interface tweak to the boost range library, which has already had 2 versions. So I considered this to be like, you know, boost range version 3. That's what I was thinking when I named it. And then the project kind of spiraled. Some feature creep. This is no longer going to be range v3. This is now basically STL2. Yeah. Yeah.
I just want to say that I'm really happy to see your presentation and to see the direction in which C++ is going. About 2 years ago, I kind of switched focus from C++ into Scala, and I had to ramp up a lot because I was very new to functional programming. So a lot of the concepts that you present there, they're already present in Scala, and of course Haskell and other languages. And to see, you know, this type of programming where you don't have loops and you have, you know, group by, I mean, it's very familiar, you know, for me. So it's really encouraging. So I want to thank you for it.
Yeah. Wow.
That's the way to go.
Cool. Thank you very much. Yeah. So yeah, the point was that yeah, this is very functional, and I agree. A lot of this stuff is kind of inspired by the research that I've done, the exposure that I've received, mostly via Bartosz Maluski, to the functional programming world, and I think it's kind of changed how I write code and how I think about code, for the better, I think. You know, I mean, nobody's going to be twisting your arm to write code like this. This is really extreme. But yeah, I like that I can write code like this, that I have the option to. Yeah. All right, cool. Thanks a lot, guys.